In this lecture, we will talk about point of inflection. Point of inflection, or this inflection is also known as inflection. In many books, it can spell like with Z sound, inflection or inflection. In Western or European textbook, we will find different spell for the word inflection. Theme of this is very interesting. As we know, whenever anything is going to change, we say derivative is there, that y-axis is changing with respect to x-axis. Basically, it tells us the information of change at an instant at some position x, or it can also be written as function is changing with respect to x, because we know that y is a function of x. So this all basically first order derivative is telling us the change of information at some instant. However, in point of inflection, there is an interesting theme behind it. For example, being a computing student or computing fellows, we are going to develop some application. In start of application, everyone like to use that application, everyone like to buy this application. So rate of selling that particular computing application in start is going, you can say that, like very exponentially grows. This is, you can say that the selling you can say that rate of selling of your application with passage of time. In one day, in each hour, you are selling one to one customer, but after some time popularity is reducing, so rate of selling for that particular application, or the less consumers are attracting to that particular application. So little bit, okay, you can say that it is though again it is selling, but rate is decreasing. So somehow you can say that rate is decreasing, not well. So this decreasing, this point is known as inflection, point of inflection. Once your rate is decreasing, or you can say that it is not from exponential change to the normal change, or change is you can say that something is happening in such a way that from sudden, you can say that from some point it is almost going to become normal, or you can say from normal point it is going to become an extraordinary things. So this is known as point of inflection. In simple words, if I do say like this, that the rate of application selling after some time will be decreased due to its certain fallbacks, or you can say that drawbacks or certain flaws, but it is not as it was on day first. So that on day first it is boosting, okay, everyone want to buy it, but after some time, even at this point, people don't want to buy it, but still it is selling, but it's the normal rate. So this point, you can say this point or this point from the sudden to the normal or normal to the very normal. So it is known as point of inflection. let me explain the two scenario of point of inflection. If it is going like this way, for example, increase, and at some moment it is almost for some days selling is almost same, then again after that time selling is decreasing, so it is known as, okay, let me explain it a little bit more. For example, at this point selling is increasing, your application is selling on higher rate day by day, but at some point it is normally, or you can say it is stable, but after that due to its certain flaws or drawbacks, rate is decreasing and almost one day it becomes dead. So this is basically is a kind of a curve, or it is known as a basically downward of what? Concave, downward. Similarly, if someone is going to, okay, and decreasing, but after some time it is again increasing, so this one is a concave upward. Like in a roller coaster, first roller coaster at this point, roller coaster at this point moving, but okay, without any force, but due to potential energy it is moving again here, okay, so this is a concave upward. However, once it is reaching here, almost its energy is decreasing, so it is again the net shell, for example, it is going like this, and at this point energy is almost going to over, then it is going to again this. So this point basically where the things are changing is almost zero, or you can say that there is no power, or almost instability things. It is known as point of inflection. Let me explain it with the help of some question. For example, this is a given function. X cube minus 9x square plus 7x. Okay, let's first derivative. With the help of first derivative, we are observing the normal change in it, or the function is changing. Okay, selling is changing every day. Okay, a roller coaster position is changing. So this is changing. So this is a derivative with respect to x. So we are considering it equivalent to 0 due to a critical situation. So we will get okay. However, before now again the set, okay, for this kind of a change, you can say that, so to observe the change at this point of a roller coaster or selling, so again take the derivative, change at saddle point, so second order derivative, so 6x minus 18. So this is a constant. So if the line is a constant, there is no slope, so it's at maybe height, okay, on x-axis. This is the x-axis, this is y-axis, this is the 1, 2, 3, 4, 5, 6, 7. 7, okay, 1, 2, 3. So this straight line, so no derivative, no slope, so it's almost 0, okay, it's exactly 0, you can say. Now we have this one, 6 x minus 3. Now again we are considering it the second order, this is for considering it equivalent to 0, we will have x minus 3 or x equal to 3. Now the situation is this, very interesting situation. Consider on a real line, x-axis, okay, on x-axis this is the point 3. If we are going on the right hand side, the curve, okay, of course it will become you can say that more points or more selling or more energy is there on the from 3 to 4 more, okay, plus things are there. So what will happen, the concave will this formation, concave upward if it's going to this side, and if it is going to this side from 3 to 2 it is getting less, so concave downwards. Basically point of inflection is also known as concavity transition. Concavity transition. So of course it can in increased case it can go up to any extent, or you can say plus infinity, and in decreased case energy is decreasing, okay, it can go to negative infinity. Now we will have one thing, that the intervals in this concave downward interval is minus infinity, this one, and in the upward we will have 3 to positive infinity. However, remember this is the x-axis, okay, this is the x-axis, value of x. These are to the you can say that the extreme situation for the downward curve and the upward curve. What we need to do, we need concavity transition between the two curves, downwards and upwards. So for this purpose we need to consider the original function. Original function is f of x as the first one, okay, the given statement 9x square plus 7x. As we already, okay, got x equal to what? 3. From this we got x equal to 3, okay, second order derivative. Now we need to what? This is the basically y. Y is the function of f of x, so y. By substituting the value of x here, we will get 27. So what? 81 plus 21. So answer is what? Answer is very simple. So we can say that minus 33. So y is minus 1, x is 3, then y is minus 33. These are the, basically this is what? This is point of inflection. This is point of inflection. So this, for example, this one somewhere this, okay, this one is a point of inflection, or the curve any between the upward curve or the downward curve, or downward curve or the upward curve. This one is the downward curve and this one is the upward curve. So transition between downward and upward, it is known as a point of inflection. Let me explain one more thing. For example, once the player who want to jump on a pole, there are certain matrices. First they are getting a jump on a pole, and after that they are stepping into the mattress, and certain buoyant force push them up. So at that pushing point, it's a point of inflection. Let me share one video with you. This is the very famous. Okay, I'll share this video for explaining the mean value theorem, Rolle's theorem, as well as the other stuff. Let's see.
I znowu staną kibicem Armii.
See how she is taking jump. So the curve is
Mondo, ten plaster taki zawinięty, przewinął go i gdzie będzie? Podniósł trochę uchwyt. Podniósł
there's a
trochę
first
uchwyt.
downward curve.
Zabawa się
Once he is
zaczyna.
taking initiative.
Ruszy za chwilę Mondo. I kto wie? Pięknie płynie po tym rozbiegu. W górę Mondo! Jest!
Yes. You noticed?
Ależ to był...
You noticed there are three curves. First one is a bending in a you can say rod, and the second one he is jumping in the form of curve on a height rod. You can say that on the pole, then the rod on a pole, horizontal rod, and after that he is jumping on a mattress. Mattress is pushing due to certain first, according to Newton law of motion, mattress is pushing the player upwards. So where he is touching or landing on a mattress, at that point is known as a point of inflection. Let me share one more video with you people for you understand. Okay, let's talk about a little bit more advanced version of the mean value theorem. You can say that mean value theorem is just, you can say that mean value theorem. Very simple. If you want to travel from Haripur to Islamabad and you cover a distance of 30 kilometer, 30 kilometer in a, you can say that in a 2 hour, okay, let's suppose on maybe not 2 hour. This is an assumption distance, okay, it can be, or maybe in reality it's almost near to 60 kilometers from distance, 60 kilometers in 2 hours. Speed limit on a motorway is almost, you can say that is okay, suppose 80 kilometers per hour. Once you reach the Islamabad toll plaza, police inform you that you are overspeeding, or you are speeding, speeding the car with more than the specified limit, speed limit. So how they checked it? Because from Haripur toll plaza you entered, you checked in, and at the point of you checked out, there is a total time. But if time is higher, it may possible due to certain break on a motorway, or you can do rest on some. But in you are reaching the checkout point a little bit earlier, then it's the cautious thing. So you did not fly. Of course, you run on a motorway. Your car is getting boosting its speed. So in the numerator, of course, distance travel. In the denominator, the time elapsed. Okay, so there is a some point, and this point is kind of a derivative, because they want to check out some here limit. Okay, limit is working where they are approaching to 0. So somewhere at particular point you are overspeeding. Due to that reason you can reach there. So this one is the third point. So by substituting this value, okay, this is the final. Let me distance traveled from 0 to 60 kilometer and time. Okay, so you can say that 30 kilometer per hour. Oh, it's fine, it's within the speed limit. But what will happen if you are covering this distance instead of 2 hours in point? This is okay. If the distance travel v minus a time elapsed, so there is some point on a open interval, you can say that is a strictly less than b, or you can say that on x-axis you can say close interval x and b. Okay, continuous. Okay, this one is differentiable. Remember, there are two things. Okay, in your textbook notion you can find the two things. One thing is talking about the differentials. Differential is changing. Okay, differential, this is talking about the differentials. Okay, from start to the end point, different speed is changing. Speed is changing whatsoever. So it is the differential. Differentials are differentiate, and with this from point A, but C is strictly greater than A and less than B. That is in a closed open interval, and but they are saying continuous from, that is the A to B. Okay, from A to B on the x-axis it is continuous. There are other words written in the definition, textbook definition, continuous. So this one is the time elapsed. As time is passing by. So, but in the some short span of a time, you can say instead of your 60 kilometer distance is covered in a 0.2, okay, or 20 minutes, 0.2. Then your this, okay, change at some particular point. What will the answer of this? So okay, kilometer per hour. If you are having some super fast car, so maybe it can have 3, but that is okay. At some point your car speed is touching 300 kilometer per hour, so you are getting a, police is putting you on charge, or you are in trouble. Are you getting the point? That you covered your distance of 60 kilometer in 20 minutes, somehow representing 20 minutes. Okay, so you are in trouble. I hope it will little bit understand for grabbing the concept. Thank you. Okay, from suppose 50 100 or some of 150 or touching 200. See, if this is reaching 200 and again car is stopping, okay, from your journey on some way, on a motorway, car is reaching to speed of 200 and again it is coming back to the zero. Of course it will touch to some point 100, it must touch any point 100, 27, 50, 150 during its movement from 0 to 200, two times. Once in a forward, okay, this one is the forward, once needle is moving to 200, and second one in a reverse direction, once car speed is getting slow, so one is on a reverse way. So two times it is any point. Therefore in mean value theorem they said that at any speed, okay, f dash of c, in representing any change at an instant, this change is representing any midpoint or any point, and maybe in the start 50 or maybe 150 km per hour, some speed. So C is between A and B. Thank you.